In this video, we're going to start learning about using our Ajax endpoint, and we're going to start with this little search here. So if I were to search for coffee, what should happen is right below it, it should automatically autocomplete a list of stores that either have coffee in the name or coffee in the description. So there's a couple new concepts that we're going to learn about MongoDB here, other than the res.json in Express to actually send stuff back as JSON rather than actually dealing with it in HTML. So first thing we need to do is learn about this concept called indexes. And I think the docs do a great job talking about what indexes are. So I'm going to read through it and we'll sort of riff on it until we understand. So indexes support the efficient execution of queries in MongoDB. So what does that mean? Indexes make things fast. Without indexes, MongoDB must perform a collection scan, i.e. scan over every document in the collection to select those documents that match the query statement. So what does that mean? Let's say I have 10,000 stores and I'm going to search for coffee. What MongoDB will do if you don't have it indexed is it's actually going to just go over every single document in your collection and say, do you have coffee in the title? Do you have coffee in the title? Do you have coffee in the title? And what indexing does is, as a developer, you say, okay, I understand that we're going to be doing a lot of queries with this field title and a lot of queries with the field description. So we tell MongoDB ahead of time, hey, it would be great if you did a little bit of homework with these fields. If you maybe read over them really quickly so you sort of know what's in them, so that when I do a query against you, like .find, then you're already going to know what is in those, and you can do a much faster, much more efficient execution of the query. So that's really great because I use MLab to do all of my hosting, and every week they send me an email and they say hey, you are performing this specific query 10,000 times this week, and you're not indexing it. Let's say I was searching the database for videos that match a specific course of mine, and it was saying, hey, you're always looking up videos that have a code called React, and you're not indexing it. So the query is taking 200-300 milliseconds to actually execute. Whereas if you told us to index it, we could sort of get the house ready. We could get stuff ready so that when someone does query us, we can do it in a number of milliseconds rather than 200-300 milliseconds. So as a developer, if you know that you're going to be hitting a field, if you're going to be searching by a field very often, it is good to index it. And we're going to go over an example of how to index text right now. And then we're also going to go over an example of how do we index our latitude and longitude. So let's go over to our stores.js or store.js model. And all of your indexing will always happen in your schema. So that's what we're going to do. We're going to go down right below our schema here. And this is where we define our indexes. One thing before we actually get into defining our indexes, if we go back to our MongoDB compass here and we go to stores, you're going to see that there is an indexes that we can go to here. And by default, your ID will always be indexed because that's the fastest way to look something up. However, if you go to users, you'll see that we're indexing ID. That's by default. And we're indexing email. And that's because our users, we have that plugin, and that plugin has likely introduced an index for us because that plugin always looks up people by their email address as well. So those are two indexes. We're going to learn about a couple more indexes before the end of this course. So we only have our stores, we only have ID. But if we go here and we take our schema and we add an index of, and we tell it here, which fields would we like it to index? So it's an object, and we tell it we want the name field to be indexed because the name of the store is important to be searched by. And we want the description of the store to be able to search by. So we take our name and we're going to index it as text. I'll talk about that in a second. And same with our description. We're also going to index that as text. Another interesting thing about indexes is you tell MongoDB what you would like it to be indexed as. In our case, we're indexing it as text because that's going to make it possible to search within that very efficiently and do some stuff like case sensitivity and whatnot. So we have our index for name and description. And if you go back to your MongoDB compass and click on refresh or apply, I think apply will do it. And you go to indexes, you should now see you have name underscore text, description underscore text. So this is what's called a compound index where it has two fields being indexed as one. And the type of it is text. and it tells us the size because it does take a little bit of space up in your database or on your hard drive because it does need to save some metadata about it, and it will tell us that it's a compound index. If it doesn't show up, I have had to quit this application and start it again to make it show up. So don't worry too much if it doesn't show up immediately. It will be working in just a second. And again, if you have a larger database, sometimes it will take a little bit of time to actually index the entire database as well. In our case, we just have a dozen or so stores. So now that we have that indexed as text, it's going to allow us to search via both of these fields in one shot. So let's go and create our new route. And this is going to be our API endpoint. So let's go into index.js and go all the way to the bottom here. And I make a new section for dealing with the API. These are where our API endpoints are going to be. So say router.get. And I like to prefix my endpoints with /API/search. Some people also like to version their API. So if you like version 1, and that's really nice because if you do make changes to your API and people are relying on it, you can just make a version 2 of that. Well, that one will stick around. But in our case, I'm just going to keep it simple. We have /API/search. And when that runs, we are going to catch errors and going to make a new method on our store controller called search stores. Okay. Then we will go to our store controller and make that search stores method. So go to the bottom here. We'll say exports.search stores is equal to and a sync request and a response. And from that, let's just say response.json. We'll give a it worked. There we go. Nice little object that we're sending back. Sync. There we go. So /API/search, hit enter. There we go. It worked. By the way, if you're wondering why mine looks like this, I'm using a plugin called JSON Viewer. And what that will do is it will give you some nice looking layout if you ever hit a JSON file. Otherwise, the raw will just look like this for you. But you probably figured that out by now. So now via this, we're going to take in a parameter called a query or Q. So we will go on the end of this and we'll say Q equals beer. And what this will do is we will take all of the query parameters, in our case, just one called Q, and we're going to pass it along. We're going to take that beer and then search our database for anything that includes the word beer. But for now, let's just double check that we actually are getting our data. And the way that you can access these parameters right here, these aren't really params, they are queries. So we go to the request and we just send the query back. And when you refresh, I'll request. There we go. You see Q is equal to beer. But if I were to add multiple query params onto the URL, name equals Wes and cool equals true, hit enter, you see that all of these queries are being passed along via the URL. So request.query.whatever it is that you're expecting. In our case, we're looking for Q. So let's go ahead and find our stores. So we say const stores equals store.find. And let's just leave it at that right now. And we'll take our stores, or we have to await them because it's asynchronous. And then we'll just say res.json stores. Then when I refresh here, I should just get a list of all of my stores being sent along. Good. So that's every single store. We don't necessarily need that just yet, but we can see that our actual API endpoint is working just fine. But what we really want to work on here is that this find needs to take an argument, which will tell us to search for the name property right here and the description property for whatever the person passed along with Q. Okay. So we open up a object here and put it on its own line. Normally it'd say something like the name includes the query, but then also or the description includes the query. And what happens when you get into like really complex queries? Do you have to take them out? No, because what we did here is we have indexed those two fields into what's called a compound index, and we've indexed them as text. So what we can do is we can use a MongoDB text operator, which will perform a text search on any fields that are indexed with a text index. So what we did by indexing them as text is we essentially said these fields are indexed as text, and we can perform a search on anything that is text. So we'll go back here and we'll say the $text, that's the operator. And we're going to open that up. And there's a couple options. And the first obvious one we need is the search. We want that to be the request.query.queue. And there's a couple other operators that we have here with our .text. So we can say language, and this will determine what language it is. Case sensitive, by default, it's case insensitive, meaning that if you have capital B beer or lowercase b beer, it'll do both of them. And then diarrhea, diarrhea sensitive, whatever that word is. I had to Google it, but what it means is that if you have like a accent aigu in one of your words, then it will just treat it as a regular E. So if somebody is searching for resume and you search for resume, then it will ignore the accents and everything on that letter. So we don't need to pass any of these case sensitive or diacritic sensitive because they are on by default. And I can't think of a whole lot of situations where you would want to turn them off. So we have that search coming in so far. Give that a save. Now, if we go back here and refresh this URL here, you'll see that we only now get 1, 2, 3 things back because I searched for beer. If I search for bread, we get nothing because there's no stores with that in there. Let's take a look at some of our other stores. Sour, let's try that. One store, because one store has sour. What about coffee? Now, the one thing that's wrong with this search for coffee is that it doesn't put them in any specific order. It actually just brings them back in the order in which they were added to the database in the date created. So what we need to do is now sort these based on some sort of score or invisible field that will allow us to see, like, if this one says coffee a couple times and the one at the bottom only says coffee once, then you want to score the one with the highest score first, and obviously the one with the lowest score last. So that's where we start getting into what's called metadata in MongoDB. And if we look at this meta operator in MongoDB, what this does is will allow us to project, and project in MongoDB is a fancy word for add a field. It will allow us to add a field using some of this hidden data that MongoDB has about our search result, and we can add that to the actual end result. So we take our find here. Our find has one argument, which is a query. Good. Now we can have a second argument here, which can also be an object. And we are going to tell it to project. Again, project means add a field. We're going to tell it to project a score field. And the score is going to be made up of the metadata, which is something called a text score. And the text score is the only metadata that is currently in MongoDB. I'm not sure if they have plans for adding more, but in this case, when we search for beer, it's going to give it a score of how close to that did we actually get. So we just projected a score on there. I'll give it a save and refresh this. Now you will see, let's take a look, score, there we go, 0.5454444. This one, 0.8. This one, 1.2. You can see that it's actually climbing, and we want the other way around. Mulberry coffee, it's in the name, it's in the description. So how do we then order that in the opposite order? Well, we can take this semicolon off, chain on a dot sort, and we want to sort it based on our new meta property, which is score. And the value of that is going to be meta and text score once more. And that should take our meta value, which is score, and sort it by that actual value. So refresh this now, and you see that our top scoring one, 1.29, is at the top, and the lowest scoring one, 0.54, is at the very bottom. So if this looks a little bit weird to you, it's because there's a lot of nested objects in here. What I do like to do sometimes is to put a find on one line and then a sort on the next, and you can write little comments. First, find stores that match, then sort them. And then finally, we also want to only return 5, because if we had 10,000, we only want to hit the top 5. So we can limit to only 5 results. So we say dot limit 5. You see how you can like sort of chain, find, sort, and limit all along in one query? Very nice that way. So that's the first half of actually creating our API. On the next video, what we're going to do is we're going to go on our front end and use that to actually pull it in when somebody searches in that search bar.